Okay, practice problem number 4 is an actual MCAS question. It's one of the constructed response or open response items that has a bunch of parts. We're going to be using scientific notation numbers to compare the size of 3 different objects. 2 large ones, the Earth and Saturn, and something much smaller, a lacrosse ball. Part A asks us what is the radius of the Earth in meters written as a single-digit number multiplied by a power of 10. A single-digit number multiplied by a power of 10 is just a fancy way of saying scientific notation, or a lengthy way to say scientific notation. So we're going to take Earth's size, 6,387,100 meters, and convert that into scientific notation. We'll full screen the whiteboard. We see here the decimal place would have to, or the decimal point would have to move to get this to a single-digit number 6 places to the left. Anything in the single millions, or in this case 6 million, is really 10 to the power of 6. And I could write 6.387, but since it's just saying a single digit number times a power of 10, I'm going to estimate and say Earth is about 6 times 10 to the 6th meters if we're measuring the radius of the Earth. Part B. So again, you could have 6 times 10 to the 6th. If you wrote 6.3871 times 10 to the 6th, I think that's fine for part A. Either one would be getting credit. Part B tells us that the radius of Saturn is approximately 6 times 10 to the 7th meters. They want us to use our work from part A, how we wrote the Earth's radius as a power of 10, to figure out how many times greater the radius of Saturn is than the radius of Earth. And again, we're going to be estimating this here. So that's why I've already estimated Earth down to 6 times 10 to the 6th. Saturn has the same coefficient, 6. So they're both starting as the same number, but Saturn gets multiplied by 1 extra power of 10. So I know Saturn's number is 10 times, or about 10 times greater than Earth's. 60 million meters as opposed to 6 million meters for Saturn. So your answer to part B would be explaining how it's 10 times greater for the radius of Saturn than Earth. Part C, and I know I'm moving quickly, sorry about that. The radius of a lacrosse ball is approximately 0.032 meters. We have that written here. Estimate the radius of a lacrosse ball. Again, we're estimating here by expressing it in scientific notation, or as they're saying, a single-digit number multiplied by some power of 10. So if we full screen that whiteboard again, 1 second. 0.032. If we want to get that to a single digit number, the decimal point would need to move 2 places to the right. That's going to be 10 to the negative second. So we're going to have 3, this coefficient 3, we're estimating 3.2 off to 3. 3 times 10 to the negative second, because if you took 3 and divided by 2 copies of 10, that's what a negative exponent means, divide by the base twice, that decimal point would move 2 places to the left to give you 0.03. So an estimate for the lacrosse ball is 3 times 10 to the negative second. Part D was going to ask you to compare Earth, this one up here, with the lacrosse ball. I know that Earth, the coefficient, I'm going to actually set this division up, Earth over lacrosse. They say how many times greater is Earth as a radius than the radius of a lacrosse ball. So we're going to be comparing Earth to the radius of a lacrosse ball. Earth, I know 6 times 10 to the 6th. Lacrosse ball, 3 times 10 to the negative second. So this is double the coefficient. 6 divided by 3 is 2. And we have 6 powers of 10 on the top, negative 2 powers on the bottom. So if we divide by a negative power of 10, that's really the same thing as switching this up here. This could be rewritten more simply as 10 squared, a positive power of 10 when it's up there. Would realize 2 times 10 to the 8th for part D. That's pretty complicated. If you have questions, we went quickly. Feel free to ask me or Ms. Stewart.